Good afternoon, everyone. My name is Dr. Tio Lawal. I'm going to demonstrate experiment 14 titled Determination of Refractive Index of Convex Lens of a material and that of unknown liquid. We are going to use two methods. The first method has to do with determination of refractive index of the convex lens of the material, while the second method has to do with refractive index of unknown liquid. The apparatus needed for these experiments are: 1. You need a convex lens, you need a plane mirror, you need a plumb line, a spherometer, then you need a pin. A pin, that is what, this is the pin needed. Then you can attach something, a colored object. It's just for you to see the nature of image. If you do not put it there, it's fine, but the essence of it is just for you to see the image formed when you place it lying vertically above the center of the lens. So the procedure is simple. You are to fix the pin to the resistor stand as shown, such that the pin is going to lie vertically on the plane mirror placed on the table. So what it means is you place your plane mirror on the table, then you fix your pin on the resistor stand as shown like this. Before introducing the convex lens, I would like you to see something. Now just look at this. The image formed in the plane mirror, it is not laterally inverted. The image formed is not laterally inverted, no matter how you move it up and down. Just check the nature of the image. What I mean by laterally inverted is that the image is not coming from this side. The image is not from this side. The image still lies on the same side as that of the object. Look at the image formed. So that is when you use the plane mirror alone. But by the time you introduce the lens, look at the convex lens. The convex lens is now placed on the surface of the plane mirror. So what you notice is that at this point, you still observe that the nature of image formed is still not laterally inverted. It is still on the same side as that of the object. Now, you will now begin to move this pin up and down. If you move it to this point and you check the image, you discover that the image is now laterally inverted. But this is not the point you are looking for. The point you are looking for is the point at which there is no parallax between the object and that of the image. So you move it up, look at it, at this down, you still discover that the image is on the same side as that of the object. But by the time you move it up and down, there will be a point whereby the image will suddenly change to this side. Look at the way my hand is. So what you are looking for when the image, which is coming from this side, coincide vertically with the objects. So, and it is by the time you look at this, you can see that it is still on the same side, but at a point exactly. So this is the point, because it is now laterally inverted. So you are to decide that same point where there will be no parallax between the object and the image. So if this is the point, without tampering with this, you will take your plumb line. Look at the plumb line. You will now place it on the surface of the convex lens from the center of this. Okay, so if this is done, Then you place it beside a meter rule. This is from a point to this. So you label this according to the manual. Use the plumb line to measure distance D1 of the pen from the surface of the lens. So that one is going to be D1. This is from 32 to maybe 50. That is D1. So your D1 in centimeter. Then you remove the lens. Then you also place the plumb line from the center of the pen to that of to the surface of the plane mirror. Then you equally place it beside a meter rule. Then when you look at this, this is from 33 to 50 something. So this will be your D2, also in centimeter. Now, from the expression in the manual, you have your F, which is the focal length of the lens, to be equal to D1 plus D2 all over 2. So this is the focal length of the convex lens. Now, you now repeat this 4 more times, okay, and you find the mean of F. So now, there are some things you need to note here. Why don't we use, these are some of the questions, why don't you use the meter rule? Why? Because at the end of the day, after using the plumb line, you still transfer it back to the meter rule. Yes, the essence of this is that we are dealing with a plane surface. Now, there are some error attributed to it. So this error is what you try to guide against. Error due to the apparatus you are using. If you use a meter rule, it's not going to point to the surface of the mirror itself or the surface of the lens. So that's why you are using, that's why you have used the plumb line. So that's number one question that may be bothering you, that I expect you to ask. Number two is that why do I have to repeat my measurements 4 more times? You are trying to guide against what is called random error. Random error can be reduced by repetition of your measurements. When you repeat a measurement over and over, you are trying to remove or eradicate random error. So that is the first part. So the next thing you are going to do is that you are provided with a spherometer. The spherometer is to measure what is called H and L. And what do we do to obtain our L? That is according to what you have in your manual. Now, to get your H, you are going to place the spherometer. You place the spherometer on the surface of the plane mirror. And you ensure that spherometer has 4 legs, 1 in the middle. There are 3 others, 1, 2, 3. Then you have this, making the 4th one. So you ensure that you use this key and make sure that all the 4 legs touches the surface of the plane mirror. And by doing that, to check if the 4 legs actually touches the surface of the plane mirror, you use a plain sheet to see if the paper actually moves in. Okay, if the paper can pass through any of the leg, then that means the spherometer has not yet touched the surface. So look at what I'm trying to do. You can see that this is not going in. This is also not going in. This is also not going in. Then look at these two. Okay, can you see? So it means that all the 4 legs of the spherometer, they've actually touched the surface of the plane mirror. So what do we do next? What you do next is you will now measure your T1. Now, this is like a micrometer screw gauge. It has a main scale and it has a vernier scale. The main scale is what you have here. When you look at what you have here, you see that you have your main scale is at 0. Look at the point mark here. That's what I'm trying to look at, the plumb line. Can you see this? The main scale here, this is the main scale, and this is the vernier scale. So this is at 0. Then look at where this one is. This is at 10. This is 10. I'm sure you still remember how you make use of a micrometer screw gauge. So what you do is you note this. This is 0 plus this is like 10, and that 10 you multiply by 0.01, and that will give you the value on the micrometer scale. So you add whatever you have here, which is 0, plus whatever you have here. So the reading that you obtain when you place the spherometer on the plane mirror, that one can be regarded as, this is T1. Yes, on the plane mirror, yes. Whatever value you have here on the plane mirror, you regard it as T1. Then you do same for that of the lens as well. You do same for that of the lens by ensuring that the forelegs touches the surface of the convex lens, and you equally check that is the paper going through any of the leg. If the paper is not actually moving out, then that means the forelegs have actually touches the surface of the lens. Then you equally do same, just like we have done earlier. Note your main scale reading here, then note your micrometer scale reading here, and whatever you have, add your main scale to that of the vernier scale, and whatever value you have, you regard that one as T2. So your H, according to the manual, your H is T2 minus T1. You know where T2 is coming from? T2 is coming from when you place your spherometer on that of the lens, and the T1 is coming from when you place your T1 on the surface of the plane mirror. Mind you, the unit of spherometer is millimeter. So I'm sure you note that whatever reading you have here is in millimeter. The reading you have here is also in millimeter. So I believe that is how you are going to get your H. Now, to now get your L, also as part of the procedure, you are to measure H 4 times and take its mean. That means you have to place this on the surface of the lens. Okay, do it for the first time. Get your T2. Okay, do this one for T1 too. Do it 4 times. Get your T1. Then find the mean. I've told you the reason why we had to take readings many times in physics is just to remove, to eradicate random error. Random error is error due to the observer, the person performing the experiment itself. While systematic error is error due to the apparatus you are using. So those are basically the 2 types of errors that we have. So as far as this is done, the next thing you have to look at is to obtain your L, and the L, which is the capital L. The L can be obtained by taking look at the spherometer. You just measure the center of the spherometer. That's making use of your meter rule from the center to any of the 3 other legs of the spherometer. Like this, they should be the same. Like this or like this. So that is how to get your L. Don't forget, from the center of the spherometer to any of the legs. So that is how to get your L. So measure the distance between the leg at the center and any other 3 legs 4 times. Find their mean and record this value as capital L. So if this is done, you are to get your capital R, and R is given to you. The expression of R is given to you in the equation by using Pythagoras theorem in one of the diagrams. So I believe your R is equal to L squared plus H squared, then all over 2H. This value was actually obtained using Pythagoras theorem of figure 14.2. That's if you thought you look at your manual. So looking at this, we have been able to obtain the first set of experiments, okay, that is determination of refractive index of a material. So the next thing you want to do now is to determine the refractive index of unknown liquid, and this is very, very simple. You want to determine the refractive index of the unknown liquid, and what you do is that you still repeat what I did earlier. Then the only thing you are introducing now is to add a drop of water on the surface of the plane mirror. Then you place your lens, the convex lens, on it. Then you repeat what we did earlier, okay, by moving it up and down, okay, till you have your laterally inverted image, okay, after you still remember, such that you are going to have the focal length. You know, by the time you take it up and down, then you remove it, you use this to get your you use the plumb line to get your D1. You remove this. You also use the plumb line to get your D2 from the surface of the plane mirror. Then you place it beside the meter rule. We've done this. The only thing we are introducing is the unknown liquid. So basically the difference between this approach and the former one is the introduction of the unknown liquid. But this time around, the unknown liquid we are talking about is water. So I believe that is done. So the F that you have here now, the focal length of the lens you are going to obtain here is capital letter F. Why the F that you obtained earlier is small letter F. All of these are well written in the manual. And at the end of the day, you will now use the expression 1 over F1 to be equal to 1 over capital letter F minus 1 over small letter F. This is the focal length of the lens when you introduce unknown liquid. This is the focal length of the lens when there is no liquid. This is as if air to glass. This is as if water to glass. Okay? So that is the demonstration needed for this experiment. All other things, the manual is well explanatory. Good luck. Thank you.